In this lecture, we are going to look at the nomenclature of binary ionic compounds using main group metals and transition metals. So, obviously, ionic compounds contain ions, but the biggest thing to remember is that they are neutral compounds overall. So there's no pluses or minuses when we write these compounds. So we are going to look at, like we said, binary ionic compounds. Binary means two, like riding a bicycle has two wheels. So there are two different species or two different elements in a binary ionic compound. All right. So here's some rules. We need to identify our main group metal cation and our non-metal anion. So like we said, that's called a binary compound. That means that there's two of them. So if we were to look at this first example, Li we need to identify as, if we look over here, Li we know is lithium. And lithium always, everybody in this whole first group of the alkali metals always has a +1 charge. So we need to recognize its charge. And then Cl is chlorine. So we need to look at chlorine, and over here in group 7A, everybody in this family, the halogens, everybody has a -1 charge. So we need to know that. So chlorine is -1. Now, the biggest thing that we just said in the prior slide was that they are overall neutral. So if I look at lithium with a +1 charge and chlorine with a -1 charge, we know that +1, -1 add them together, and that is neutral. So we are able to say, hey, lithium chloride is an overall neutral compound with 1 lithium and 1 chlorine atom together. Now, when we name this, we know that from the previous lecture, we would call lithium a lithium ion, and chlorine would become a chloride ion. So therefore, when we put two ions together, we write it as lithium, and then we take the chloride ion and we drop the ion, and then we just say chloride. So lithium chloride is the name of that compound. Now let's look at the next example, MgCl2. We know that Mg is magnesium. And again, if we look over here at this periodic table on the right, it's in group 2A. And Mg is always Mg2+. So I'm going to write a 2+ up here. And then just like we know with chlorine, chlorine is always a -1 charge. So if we were to write out the name of this, we've got magnesium ion and a chloride ion. So we put them together and it becomes magnesium chloride. Then we need to look at it, make sure that it's overall neutral charge. So with magnesium, it's a 2+ charge. So we have, and it tells us since there's no subscript, we just have 1 2+. With the chlorine, it tells us that we have 2. That subscript says I have 2 chlorines. So I have a -1 and a -1. So therefore, a 2+ and 2 minuses is equal to 0. So that is a neutral compound. Let's look at AlCl3. Again, if we look over here and find aluminum in group 3A, we know that aluminum is a 3+ ion, and there's one of them. So up here, I'm going to write Al with 3+. Now the chlorine, again, still a -1, and it tells me that I have 3 of them. So I have a Cl-, Cl-, and a Cl-. Notice that, again, this is a neutral compound because I have a 3+ and a minus, that's 3-. So 3+ with a 3-, add them together and we get a neutral compound. So to write this compound's name, we have an aluminum ion, so we have aluminum, and chlorine becomes chloride, so aluminum chloride. The next one we're looking at is Al2O3. I'm doing down here. Similar, we know that Al is aluminum and O is oxygen, which turns to oxide. Now, as far as looking at its subscripts, let's figure out why it's written that way. Again, we know aluminum, you have to be able to recognize that it is a 3+ ion because it is in group 3A. My oxygen is, if we go over here and find it, 6A, we have O is a 2- ion. So we have, it tells me that I have 2 Al3 pluses. So Al3+, Al3+. And then it says over here that I have 3 oxygens. So O2-, O2-, O2-. So I have a total of +3 and +3 is +6. And all of these O's, -2, -2, -2 is -6, giving me a neutral compound. All right, let's look at this last one, Al and N. So again, we know Al is aluminum. N we know is nitrogen, which turns to nitride. And if we look at charges, aluminum, like we just have been saying, was 3+, and N over here on the periodic table is 3-. And just by looking at this, a 3+ and a 3- is a neutral compound, so we only need one of each of those for aluminum nitride. Now let's see about, if we're given the name, how to write it. So potassium, again, look over here. K is in my very first family, so we know that potassium is K and it's +1. And oxide, we know is oxygen with a 2- charge. Now to get to a neutral compound, we know that +1 and 2- does not equal 0. That actually equals a -1 right there. So I need to add another K +1, so I can have a +1 and a +1, which is a +2, with my -2 to have a neutral compound. So this compound would be written K2O for potassium oxide. And again, remember that this compound does not have any pluses or minuses in it. All right, let's look at potassium bromide. Again, we know K is always +1. Now let's look at bromide, which is bromine, and it's over here in my halogens, group 7A. Br is a -1. And just by looking at this, a +1 and a -1 is equal to 0 right off the bat. So we can write this compound as KBr, potassium bromide. Now let's look at aluminum sulfide. Aluminum, just like up before, always, aluminum is a 3+. Let's look at sulfide, which is sulfur. S is always a 2-. Okay, so if we look at this, a +3 and a -2 does not equal 0. So I need more negatives. So let's do an S2-. Now I have -4 on the right and a +3. That does not equal out to 0. So we add another aluminum. Now I have +6 on the left and -4 on the right. They're still not at a neutral compound. So we need to add more negatives. And this would give me +6. And this gives me -2, -2, -2 is a -6 for a neutral compound. So this would be written as Al2S3 because it took 2 aluminums over here, right? 2 Als and 3 sulfurs right there. 1, 2, 3 sulfurs. So Al2S3 would be that compound. So it is really important to see that those subscripts, those formula subscripts, tells me how many of those ions are present in the compound. The charges of the ions are implied because of where they are located on the periodic table. Again, if you're thinking, how is that potassium +1? How did we know that this was +1? Because it's in the first group on that periodic table. All of these elements in that first group are all +1s. How did we know oxide was a -2? Because everybody in this group 6 is a -2. Because if I were to draw oxygen, recall back, oxygen has 6, it's in group 6, it has 6 outermost electrons, 5, 6. It wants 2 more to have a full shell. When it gets those 2 more, that's going to fill up right there and right there, it now has a -2 charge because it grabbed 2 more electrons from somewhere, and because it grabbed 2 more electrons and electrons are negative, it now has a -2 charge. So you have to be able to look at the periodic table. It is so helpful for this. So let's do 2 more examples just to make sure that you're good. Let's say I took calcium and I combined it with nitrogen. So I have calcium nitride. Calcium, if you want, actually, why don't you pause the video here real quick and try to do calcium and nitrogen and sodium and oxygen. So pause real quick and see what compounds those make. Okay, let's see what ion calcium makes. Calcium right here makes a 2+ ion, and nitride forms a 3- ion. So when you start to get the hang of getting a neutral compound, we got to have the same number of positives and negatives, right? And I look at this and I go, well, my least common multiple that they're going to have in common is 6. So how do I get calcium to 6? Well, I'm going to need another Ca2+ and another Ca2+. That gets me to +6. And my N, how do I get to 6? If I'm at 3-, I need one more N, 3-. Now I've got both of these together is -6. All of these 2 pluses is +6. So my compound would be Ca3N2, calcium nitride. And then if we look at sodium, again, we know sodium over here is in that first column. So it's Na+1. Plus just means 1 after it, the 1's implied. And O again over here is 2-. So I have 2- and only 1+. I need one more +1. So now I have +1 and +1 is +2. And over here I have -2 to equal out to 0. So my compound would be Na2O. Okay, so hopefully you were feeling pretty good about binary ionic compounds. Binary, again, is 2 different elements, a metal and a nonmetal. Now we're going to continue with ionics, looking at binary ionic compounds, but the only difference here is we're going to look at transition metals. So before, when we were looking at, let me go back to this messy picture here, we were really focusing on our main group elements in period 1, period 1A, 2A, and 3A. And then, of course, my nonmetals over there. But for this next chunk, we're going to look at these transition metals, that middle section. So what's interesting about the transition metals is those ones don't tell us, if you look right here, does not tell us what those charges are going to be. Unlike lithium, sodium, potassium, all these are always +1. These are always +2. These are, aluminum is always 3+. But when we look at the transition metals, we need to figure out the charges before we name them. So we still have the metal always listed first. We're still going to name the metal just like normal. But the difference is we need to put Roman numerals there to show us the cation's charge. And then we still will name the nonmetal the same. We put the nonmetal and put the ending of "ide." So we know that Fe is iron, and I know Cl is chlorine, which turns to chloride. But I don't know what iron's charge is. It's a transition metal. I need to figure that out. But what's great is this tells me that I have 3 chlorines. We know that chlorine always has a -1 charge. So if I have 3 chlorines, I have a Cl minus, a Cl minus, and a Cl minus for a total negative charge of how many? -3. So what must, and there's only one Fe, Fe must have a charge of what? Of +3 in order to be a neutral compound. And it's telling me that this is my compound, FeCl3. So now we solved the missing piece of what is iron's charge. It's +3. So I need to write out of iron, and then I would put in Roman numerals 3, 1, 2, 3, and then I would just say my chloride is, ta-da! Okay, so now let's look at FeO. Again, if we go back and look at my periodic table here, we know that O is always 2 minus. So I'm going to go here and I'm going to put above it, it's 2 minus. Now there's only one O and there's only one Fe. So Fe's charge, in order to have that neutral compound, Fe must be 2 plus, right? Because 2 plus and 2 minus is equal to 0. So we would call this iron, Roman numeral 2, and then O is oxide. Okay. Now let's look at this one. Here's another iron oxide. This one is iron 2 oxide. Now this one is FeO again, but there's 2 O's. Well, again, we always know that O is 2 minus. Here it's telling me I have 2 O's. So I've got O2 minus and O2 minus for a total negative charge of 4 minus. I have 1 Fe. So if I have 1 Fe and I need a neutral compound, this must be 4 plus. Because 4 plus, plus 4 minus is equal to 0. So I would name this, so this would be Fe plus 4 and minus 4 is 0. So I would call this iron, and then Roman numeral for 4 is Iv, and then oxide. So here I do have iron 2 oxide, and over here I have iron 4 oxide. Okay, let's keep going. Again, we know chlorine is -1, and I have 2 chlorines. So I have Cl minus and Cl minus for a total negative charge of -2. So what must chromium's charge be? Cr must be a +2. +2 and 2 -2's is equal to 0. So I would say chromium, and then parenthesis, again, it's charge 2, and then Cl is chloride, chromium 2 chloride. Okay, so now here we have another chromium with oxygen. Again, I don't know what chromium's charge is. Transition metals can vary their charges. So I do know oxygen always, always, always is 2 minus, and I have 3 of them. So I've got O2 minus, O2 minus, O2 minus. Now chromium, this tells me that I have 2 chromiums. So I've got a Cr and a Cr, and I don't know what its charge is, but I do know that both 2 charges need to total up to -2, -4, -6. So what must this be? Well, a +3 and a +3 would give me a +6, right? So chromium, this must be +3. So it'd be chromium 3 oxide. And there we go. Okay, so then we have nickel and bromine. Again, looking at the periodic table, bromine is always a -1 charge, and I have 2 of them. So if I have Br minus and Br minus, I have a total negative charge of -2, which means I need a total positive charge of +2. So this must be nickel, and then in parentheses, 2, and then bromide. Nickel 2 bromide. Okay, now let's try to do the opposite. If I'm given the name, let's find out its formula. So we're told here tin, so there we go. Tin is Sn. Now this tells me that its charge is, that's a Roman numeral 4. So 4 plus, and then bromide we know is bromine, Br, and we know that bromine has a -1 charge. So how do I get this to balance out and equal 0? Well, here this is 4 pluses, so I need 4 minuses. So I need to have another Br minus, Br minus, Br minus. So I would have Sn Br4 for tin 4 bromide. Again, this gives me -4, and this is a +4 to equal 0. Now this next one is tin 4 oxide. So again, we have Sn with a 4 plus charge. Oxide, again, look at the periodic table. Oxygen has 6 valence electrons. It wants 2 more. It wants to become a -2 charge. So here I have +4, and I have a -2. So to have a neutral charge, to have that neutral charge, if I have a +4, how do I get to -4? So I would need another O2 minus. That would give me -4. So my compound would be Sn, 1 Sn, and 2 O's. SnO2. And then let's look at our last example here. This tells me tin 2. So Sn with a 2 plus charge. And oxide, we know oxide is O2 minus. So again, if I look at my +2 and my -2, that equals 0 right off the bat. So I just need 1 Sn and 1 O.